Okay, so today you're going to be analyzing a 21 resistor circuit, circuit number 4. Yeah, it's kind of complicated. There's 12 total junctions, but again, you need to use those junctions to help you with that first redraw, and that's kind of, I think, the difficult part is getting this first redrawing, getting everything so that it's horizontal and it's a little easier to see what's parallel and what's in series. And as you go along, remember, you can only combine resistors if what you're combining is either completely series or completely parallel. So here, let's go ahead and get this first drawing done. Here's the original redraw of the circuit. And you notice when you come through, when you get to resistor 1, you have a choice to either go through resistor 6 or through this mess here of resistors 1 through 5, combining back at 12. If you chose the other path, it goes through resistor 6 to junction 4, where you can either go up through this resistor 12 to 18, these 3 pairs in parallel, and then 18 off to the side here, rejoining at 9. Or you could have gone down through resistors 7, 8, 9 in parallel, 10, 11, and rejoin back up at 9. After junction 9, you go through resistor 19, and then through 20 and 21 in parallel, where it joins back up at junction 12 with that resistors 1 through 5 line back to the end of the battery. Now, in this, when I did the first collapsing, I collapsed 16 and 17, 14 and 15, 12 and 13 using the series rule. I collapsed 7, 8, and 9 here using the parallel reciprocal rule. I collapsed 2 and 3 using the series rule here. And I collapsed 21 and 20 right here using the reciprocal rule. And then you, hopefully, as you're checking along, maybe you didn't do it in the exact same order, but a little more collapsing in here. And then in this step, the only thing you can do, really, I combine these 3, 1 through 5, as a series, 12 and 17 and 18 as a series, and that's really all you can do in that step. And then one more step, all you can do is combine these right here, 7 through 18, using the parallel rule. Then you have 6 through 21 here in the top row in series. Then you end with a set of parallels. You should get a total of 3.68 ohms of resistance, along with our 24 volts, allows us, gives us 6.52 amps. And now you get to go back up through. That first resistor right here was actually 2 in parallel. So you take the voltage, the 24 volts up with you, and solve for current. Go to the next drawing up, and the only thing that changes is this resistor 6 through 21 was actually 3 in series, so that 2.03 amps goes with it. You solve for volts. And the only thing that changed in the next drawing is that this one 7 to 18 was actually 2 in parallel, so that 3.74 volts goes with you. Solve for current. And then the only thing changes in the next one is that resistor 12 to 18 was actually 2 in, 1 through 5 was actually 3 in series. So you take the 4.5 amps from way down there, solve for voltage. And then you have the 12 to 18 was actually 2 in series, so you take the 1.25 amps with you, solve for voltage. Go up to the next drawing, a lot of things changed. This was parallel, so you take the voltage with you, solve for current. That was parallel, instead of, it was 3 in parallel, so you take the 1.25 volts with you, solve for current at each one. These are actually 3 in series, so you take the 0.79 amps with you and solve for voltage. These are 2 in series, so you take the current, solve for voltage. Going up to the last drawing, resistor 2, 3 was actually 2 in series. Resistor 7 to 9 was actually 3 in parallel. Take the voltage, solve for current. These three right here, 16, 17, 14, 15, and 12 and 13, were all actually pairs in series, so you take the 0.5 amps current up to all of them, solve for volts for all of them. One last one, resistor 2021 was actually a pair in parallel, so you take the volts with you and solve for current, and that's it. Here's all the answers if you want to check that way. I hope you got them right.